Okay, so this little video is just going to show you what happens at the synapse. Okay, so as you can see over this side here, we've got a sodium channel. We remember these sodium channels from earlier, and when a high level of voltage reaches these sodium channels, they allow the influx of sodium. So let's allow the sodium in. So high level of voltage comes and we'll let all the sodium in. Oh, that was quite cool, wasn't it? So now sodium's now inside the cell, and the same happens with this channel. Sodium pumps into the cell, and at the moment this is going to be where the majority of the really high voltage is now going to be. This high level of voltage activates these calcium channels. Okay, you've got these calcium channels, and the calcium channels now open. So when they open, they allow calcium to come into the cell. Alright, so calcium is now inside the cell. Inside this presynaptic membrane here, so you've got the presynaptic membrane and the postsynaptic membrane here. So inside you've got these little vesicles, and inside these vesicles are neurotransmitters. Okay, so acetylcholine, for example. Acetylcholine is inside these neurotransmitters. Alright, and you'll notice these little strands here. These are called snare proteins. Okay, and what happens is this calcium binds to these snare proteins, and when that happens, the snare proteins hook up to these vesicles and pull them towards the cell membrane. Okay, if you notice, I've got two lines which is representing the phospholipid bilayer that I mentioned earlier. So the snare proteins now pull this vesicle towards the cell membrane. When it arrives at the cell membrane, the snare proteins hold onto the side of the vesicle, and obviously that's got a bilayer as well, and it rips open the sides. When it rips open the sides, it allows all of this neurotransmitter to be released out of here. So you get a massive release of neurotransmitter from these vesicles with the aid of these snare proteins into this area here. Okay, so as you know that the nerves don't touch each other, and this area here is called the synaptic cleft. So let's stick a load of neurotransmitter in the middle. There we go. So we've got stacks and stacks of neurotransmitter are now in the synaptic cleft. Okay, so let's think about acetylcholine then. So if you imagine that these are acetylcholine, acetylcholine will then bind to these particular receptor sites. Sometimes the channels themselves have got receptor sites on them, and when the neurotransmitter binds to the receptor site, it causes the channel to open. Some channels do not have receptor sites. So then the neurotransmitter binds to another receptor on the cell membrane, which has what's called a G protein attached to it. The G protein, once the neurotransmitter binds, is then released and binds with the channel and then causes the channel to open. So this is kind of like a little messenger, this G protein. Let's put him back over there. Okay, so if acetylcholine then comes and binds to this site here, by doing so it causes these sodium channels to open, and then sodium starts rushing into the cell, and then we get that whole process of increasing the amount of sodium to then create an action potential later on, and that's how that happens. One of the things that is also present with acetylcholine is a particular enzyme called acetylcholine esterase. So I'll stick a little acetylcholine esterase Pac-Man up there for you. So what happens here is if acetylcholine then binds to this receptor site and these open, once it's bound and something's happened, the acetylcholine is then released back into the synaptic cleft and then can bind again with somewhere else. Now you can see where this is going to be a problem. If you've got a continuing amount of neurotransmitter binding, if this is connected to some skeletal muscle which causes a contraction, if acetylcholine is always available to bind to these sites constantly, you're going to get a constant contraction that you can't release. So what we have here is acetylcholine esterase. So once the neurotransmitter acetylcholine is bound to a receptor site and initiated some kind of response, like an opening of a channel, the acetylcholine esterase then chomps up the acetylcholine. All right, so that it can't then be used again. All right, and that's really how everything works at the synapse.